Extinction is supposed to be forever. When a species vanishes from Earth, conventional wisdom declares it gone for eternity, erased from the living world. It's scattered across our planet. Creatures persist in the shadows, clinging to existence despite humanity's relentless expansion and environmental destruction. Some were declared extinct for decades, even millions of years, before stunning rediscoveries shocked the scientific community. Others teetered so close to oblivion that single-digit populations remained, saved only through desperate last-minute interventions. These are the Lazarus species, animals that rose from presumed death, defying extinction through resilience, luck, and human determination. Their stories blend tragedy with triumph, illustrating both our capacity for destruction and our power to heal. Tonight, we explore 6 remarkable comebacks that prove extinction isn't always the final chapter. The armored survivor, American alligator. In the murky waters of Florida's Everglades, a pair of ancient eyes breaks the surface tension. The American alligator, 15 feet of prehistoric predatory perfection, glides silently through cypress swamps where its ancestors hunted for millions of years. This apex reptile represents one of conservation's greatest success stories, though few remember how close it came to disappearing forever. American alligators are evolutionary masterpieces, perfectly adapted for life in southeastern wetlands spanning from North Carolina to Texas. Adult males reach 15 feet in length and weigh up to 1,000 pounds, their bodies armored with thick, keratinized scales providing protection from virtually any threat. Their jaws generate bite forces exceeding 3,000 pounds per square inch, surpassing even jaguars in crushing power. These reptiles play crucial ecological roles in their native habitats. During dry seasons, alligators excavate gator holes that retain water, providing survival refuges for fish, turtles, wading birds, and countless other species. Their presence regulates prey populations and maintains wetland health through complex trophic interaction scientists are still documenting. Yet by the mid-20th century, American alligators had been pushed to extinction's threshold. The catastrophe began in the 1800s when commercial hunters discovered lucrative markets for alligator leather. Manufacturers prized the belly skin for crafting luxury handbags, boots, and accessories commanding premium prices. Professional hunters slaughtered alligators by the thousands, often leaving carcasses to rot after removing only the valuable hide. Habitat destruction accelerated the decline as developers drained wetlands for agriculture and urban expansion throughout the southeastern states. Pollution added another deadly pressure. Agricultural runoff containing DDT and other pesticides contaminated waterways, accumulating in alligator tissues and disrupting reproductive systems. Eggshells became too thin to support developing embryos, causing widespread nesting failures. By the 1950s, surveys estimated fewer than 100,000 alligators survived across 10 states. Biologists warned the species faced imminent extinction unless drastic action occurred immediately. In 1962, Florida implemented the first protection measures, banning all alligator hunting statewide. For years later, the federal government listed alligators as endangered under precursors to the Endangered Species Act. Law enforcement cracked down on poachers and illegal hide trafficking. Education programs taught communities about alligators' ecological importance. Wetland protection laws prevented further habitat destruction. The 1972 DDT ban eliminated the pesticide's reproductive impacts. These comprehensive efforts created conditions for population recovery. The results exceeded conservationists' most optimistic projections. Alligator numbers rebounded dramatically, and by 1987, the species was removed from the endangered list. Today, over 5 million American alligators inhabit their historical range, a population healthy enough to support regulated hunting seasons, generating millions in economic activity while maintaining sustainable numbers. The living fossil, Coelacanth. December 19, 1938. A fishing trawler pulls nets from waters off South Africa's eastern coast. Among the usual catch lies something extraordinary: a 5-foot fish covered in heavy, armored scales, sporting strange lobe-shaped fins resembling primitive limbs rather than typical fish appendages. Museum curator Marjorie Courtney Latimer recognizes this creature from fossil illustrations and scientific texts. The discovery electrifies the scientific world. This is a coelacanth, a fish believed extinct for 66 million years, supposedly vanishing alongside dinosaurs at the Cretaceous-Paleogene boundary. Yet here swims living proof that coelacanth persisted in deep ocean refuges, completely unknown to modern science. Coelacanth represent one of Earth's most ancient fish lineages, with fossil ancestors dating back 400 million years. Their unique lobe fins contain bone structures remarkably similar to tetrapod limbs, offering crucial evidence about the evolutionary transition from aquatic to terrestrial vertebrates. These living fossils provide invaluable insights into ancient anatomy that no fossilized remains alone could reveal. The 1938 specimen sparked intensive searches for additional coelacanth. For 14 years, scientists found nothing, leading some to speculate the South African fish was an isolated anomaly. Then in 1952, a second specimen was discovered near the Comoro Islands between Madagascar and Mozambique. Subsequent expeditions revealed small populations inhabiting volcanic underwater caves at depths between 600 and 1,000 feet. Coelacanth possess remarkable adaptations for their deep-sea lifestyle. Their swim bladders evolved into fatty organs providing neutral buoyancy, allowing effortless hovering in the water column. Electroreceptive organs in their snouts detect electrical fields generated by prey's muscle contractions, useful for hunting in perpetual darkness. They're ovoviviparous, meaning eggs develop internally and females give birth to live young after gestation periods lasting approximately 3 years. In 1998, another stunning discovery occurred when Indonesian fishermen caught an unknown coelacanth species off Sulawesi. This second species, separated from the cormorant population by thousands of miles, revealed coelacanth enjoyed wider distribution than previously believed. Genetic analysis showed the two populations diverged millions of years ago, each evolving in isolation. Today, both coelacanth species are critically endangered. Fishing pressure, despite their unpalatable flesh, accidentally captures them as bycatch. Deep-sea oil exploration threatens their habitat. Scientists estimate fewer than 500 cormorant coelacanth survive, with Indonesian population numbers remaining unknown. International conservation efforts focus on establishing protected marine reserves and educating fishing communities about these remarkable survivors. The condor's resurrection. Gymnogyps californianus. Across southwestern skies, the largest bird in North America once soared on thermals rising from sun-baked canyons. The California condor, with its massive 9-foot wingspan and distinctive bald head, served as nature's cleanup crew. These scavengers consumed carrion that might otherwise spread disease, performing essential ecosystem services while requiring virtually no living prey. California condors evolved for scavenging megafauna carcasses during the Pleistocene epoch when mammoths, giant sloths, and other massive animals populated North America. As those megafauna disappeared approximately 10,000 years ago, condors adapted to smaller food sources including deer, cattle, and marine mammals washed ashore. European colonization brought disaster. Settlers shot condors as pests or trophies, collected their eggs, and poisoned carcasses to kill predators. Lead ammunition posed particularly deadly threats. Condors feeding on gut piles left by hunters ingested lead fragments, causing gradual poisoning that destroyed organ systems and caused neurological damage. DDT contamination weakened eggshells, preventing successful reproduction. By 1982, only 22 California condors remained on Earth. Extinction appeared inevitable within years. Biologists faced an agonizing decision: capture all wild condors for captive breeding or allow the species to disappear naturally. The risk was enormous. Capturing remaining birds might stress them fatally, and captive breeding might fail completely. They chose intervention. Between 1982 and 1987, teams captured every surviving condor, establishing breeding populations at San Diego Zoo and Los Angeles Zoo. The pressure was immense. Each bird represented nearly 5% of the entire species. Any mortality could doom the recovery program. The breeding programs succeeded beyond expectations. Biologists developed specialized techniques, including puppet feeding of chicks, to prevent human imprinting. They discovered that removing eggs stimulated condors to lay replacement clutches, accelerating reproduction rates. Young condors learned survival skills from older birds through social learning reinforced by careful human management. In 1992, the first captive-bred condors were released into California wilderness. Additional release sites followed in Arizona, Utah, and Mexico. Today, approximately 560 California condors exist, roughly 60% living wild across their restored range. The species remains critically endangered, but the population trajectory points toward eventual recovery. Lead poisoning still kills condors regularly. Conservation efforts now focus on promoting non-lead ammunition among hunters and educating communities about threats. Each year brings cautious optimism as wild condors successfully raise chicks, proving the species can sustain itself with continued support. The striped phoenix, Quagga. Imagine a zebra that forgot half its stripes. The quagga displayed bold black and white striping across its head, neck, and shoulders, gradually fading to solid brown hindquarters and legs. This unique pattern made quaggas instantly recognizable inhabitants of South Africa's Cape Province grasslands during the 19th century. Dutch colonists arriving in South Africa encountered vast quagga herds grazing alongside springboks and wildebeests. The animals' distinctive barking calls echoed across plains, giving them their onomatopoetic koi name. Quaggas proved easy hunting, lacking fear of humans and occupying open terrain, offering little cover. Commercial hunting decimated quagga populations with shocking speed. Colonists slaughtered them for meat and hides, while clearing land for agriculture eliminated habitat. The last wild quaggas disappeared during the 1860s. The final captive individual died in Amsterdam's Artis Zoo on August 12, 1883, marking the species' official extinction. For a century, the quagga existed only in faded photographs, taxidermy mounts, and historical records. Then during the 1980s, Reinhold Rau, a German-born taxidermist working in South Africa, proposed an audacious idea: bring quaggas back through selective breeding. Genetic analysis of museum specimens revealed quaggas were not distinct species, but rather subspecies of plain zebras. The stripe reduction resulted from relatively simple genetic variations rather than fundamental biological differences. This meant plains zebras carried latent genetic potential for quagga-like coat patterns. The Quagga project began in 1987, selecting plains zebras displaying reduced striping on their hindquarters. Breeding these individuals produced offspring with even less striping. Generation by generation, breeders selected for increasingly quagga-like appearance, simultaneously reducing stripe density and extent. By 2005, the project produced animals virtually indistinguishable from historical quagga photographs. While not genetically identical to original quaggas, these route quaggas represent functional ecological equivalents filling the same niche. Over 150 now graze in South African reserves, and the population continues growing steadily. The ghost primate, Pygmy Tarsier. In the mossy mountain forests of central Sulawesi, one of the world's smallest primates clings to vertical tree trunks with opposable toes and elongated fingers. The Pygmy Tarsier weighs barely 2 ounces and measures 4 inches long, excluding its tail. Its enormous eyes, each weighing more than its brain, provide exceptional night vision for nocturnal hunting. Scientists discovered Pygmy tarsiers in 1921, but found only a handful of specimens. Then the sightings stopped completely. For 80 years, no scientist observed a living Pygmy tarsier. Most biologists assumed habitat destruction and introduced predators had driven them extinct. In August 2000, researchers trapping rats in Sulawesi's Lor Lindu National Park accidentally caught a Pygmy tarsier. The capture proved the species survived, but revealed how desperately rare they had become. 8 years later, a team located and studied a small breeding population, documenting their behavior and ecology for the first time. Pygmy tarsiers occupy specialized ecological niches in moss-covered forests above 6,000 feet elevation. They're entirely carnivorous, catching insects, spiders, and small vertebrates with lightning-fast hand strikes. Their habitat faces threats from agricultural expansion and climate change, altering mountain ecosystems. Conservation now focuses on protecting these high-elevation refuges. These 6 survivors prove extinction isn't always inevitable. Through scientific dedication, policy changes, and sometimes pure chance, species on the brink can recover or resurface from obscurity. Yet their stories also remind us that prevention beats resurrection. For every successful comeback, countless species vanished permanently. The lesson is clear. Protecting biodiversity before crisis strikes remains infinitely easier than salvaging species from extinction's doorstep. Their continued existence depends entirely on choices we make today.